Let's move on to 1245. Here it says, for each of the following, calculate the z-statistic. I don't like these, but I guess they're a good exercise. What I don't like is that there's no context for any of this. These are just numbers, and so we're just kind of working through some numbers. But let's go ahead and do it. If it helps, kind of imagine some situation where these numbers seem to fit, but you'll have to make your own choices. I'm not going to go through that. So part A, and actually the second one for the next problem, 1246 is going to calculate p-values for each of these. We'll go through each of the z-statistics first, and then we'll come back and do the p-values. So for part A, it gives us n equal to 30. It gives us p hat equal to 0.6. Gives us a null hypothesis of p is equal to, what is that, 0.5? And the alternative is that p is not equal to 0.5. Okay? So, z is always going to be estimate minus a null value divided by standard error at the null. So in this case, the estimate is what?
0.6.
Okay. 0.6 minus, what's my null value? 0.5. What's my standard error at the null?
Square root of 0.6 times 1 minus 0.6 over.
If it were just standard error, that would be correct, because we had p hat times 1 minus p hat over n. That was for a confidence interval. But on Monday, what we did was we recognized that in the context of a hypothesis test, the better guess at the value of the population parameter is what we're assuming it to be equal to here in the null hypothesis. So instead of using p hat in that standard error calculation, we want to use this p0.
So 0.5.
So it's going to be 0.5 times 1 minus 0.5 divided by our n of 30. Okay? Now, when I see these in homework or on tests or anything, this is what I want to see. Because from there to here is calculator magic. And calculator magic tends to be a bit fuzzy, especially my calculator magic. When you're calculating these things, get in the habit of calculating them in pieces. So don't, I know with an HP calculator or with a TI calculator, does anybody use HPs anymore? That's what I grew up with, is HP calculators, the TI calculators. You could type this entire equation into your calculator and press equals, and it will calculate the whole thing at once more. And if I do that, there's at least a 50-50 chance that it's going to come out wrong. Because somewhere in that whole thing, I'm going to get something wrong. So get used to calculating this in pieces and writing down intermediate steps. That way, you'll have a better chance of getting it correct. But when I'm looking at this, this is what I'm looking for. If you have this, then you have the correct answer. When I look at this value over here, the actual result of the calculation, in most cases, if the result is reasonable, I'm going to give you full credit for it. If you have a negative value over here, I'm going to take points off. Because you can look right here and tell that 0.6 minus 0.5 has to be greater than 0, so this must be positive. Okay? So things like that. If you calculate a probability and the probability isn't between 0 and 1, I'm going to take a lot of points off for those. Okay? Even if you have everything right up to that point, if you write down a probability and that probability isn't between 0 and 1, I'm going to take a lot of points off because you should know better than that. Okay? Probabilities have to be between 0 and 1. So we've got a value of 1.1 here. So that's our z. That's all we really needed in this particular case. So let's move on to b. What was n? For part B, what's n? 60? P hat? 0.1. Null hypothesis is P is equal to what?
0.25.
0.25. I just did this last hour, but I don't remember them completely. So, Z is going to be what? My estimate is
0.1 minus 0.25.
okay, the numerator is 0.1 minus 0.25. That's divided by, it's going to be a square root down here. Inside the square root is
0.25 times 1 minus 0.25 over 60.
okay. Anybody calculated that yet?
Is the alternative not equal to 0.25?
What's a good point? What's the alternative up here?
0.25 is greater than P, but
So P is what?
less than.
Less than? I can't think in that direction.
But I don't think it really matters other than just for aesthetics purposes.
Yeah, it's just convention that we put it this direction. But I usually, in most of us, get into a habit of thinking in one direction or another, so it's a little difficult for us at times. So we think of this as P is less than 0.25. The other way around, as we said, that doesn't matter. You can put it the other way if you need to. Z then is minus 2.68 for this case. And we should be able to tell quickly, it ought to be a minus. 2.68, is that an unreasonable value? No. What if I came up with minus 26.8? Does that sound right?
It's ludicrous.
That, well, it's a negative, I guess.
Yeah, it's negative, but 26.8?
Yeah, no.
That seems a little ridiculous for our Z value. However, you will find cases where that is true. You will find cases where you do calculations that have come up that way. Most of the time what's happening is the observation that you're making is so far out in the weeds. For example, if I'm hypothesizing that the proportion is 0.25, and I take a sample, and my sample says it's 0.01, and that sample is any reasonable size sample, so 60, 70. My sample says my proportion is 0.01, and I'm hypothesizing 0.25. We can all pretty much look at that, and we don't have to do too many calculations. We can pretty much throw out the idea that this is true, can't we?
How would you survey a portion of a person?
That's a good question. Okay, let's go on to C. Take C, N is what? N is 500. Look at a big sample here. What's P hat?
0.3.
0.3. I certainly think that if they've got 500 people and they've come up with 0.3, that somebody did some rounding. P is equal to what? 0.2 versus P is greater than 0.2. What if my alternative had been P is less than 0.2? What would this observation mean? So let's, just as a thought exercise, so we said here we're hypothesizing that P is less than 0.2. And my observation is that P hat is 0.3. What does that mean?
Fail to accept the alternative hypothesis.
Okay? Does everybody see why that's true?